HVAC control systems are used to control the operations of heating, ventilation, and air conditioning equipment. An example of a control device is a thermostat. By lowering the thermostat, we control the functions of the air conditioner unit. Control systems manage devices or components based on the desired result. Control systems have inputs and outputs. Inputs are used to gather and respond to information. Outputs are used to control an action. Let's revisit the thermostat example. Temperature is the input to the system. We set this input by changing the thermostat to the desired temperature. The system output will respond to this information by either turning on the air conditioning or the heater. The first control systems were called pneumatic control systems. These control systems relied on pressurized air and gas to send and receive signals. These controls were sold as commercial HVAC systems by large companies that dominated the industry. As time went on, smaller companies joined the industry with electrical control systems. These control systems relied on sending and receiving electrical signals in the form of voltages. The larger companies quickly adopted these control systems. Control systems are broken down into two categories: open-loop systems, and closed-loop systems. We will see what classifies a control system as open-loop or closed-loop. In an open-loop control system, the input is independent of the output. The input will not change regardless of what the output of the system is. A toaster is an example of an open-loop system. This system runs on a timer. The set time is the input to the system. The toaster heating up and staying hot for that set time is the output. The system is open-loop because the toaster will not take into account if the bread is toasted or not. In a closed-loop system, the input is dependent on the output. The input will change according to what the output of the system is. Another name for closed-loop control is feedback because the output of the system is fed back as part of the input. An electric iron is an example of a closed-loop system. This system is used to generate heat but will stop heating when a specific temperature is reached. Here, the output of the system is temperature. The input to the system depends on the output temperature. Control is essential for systems to remain stable. Stability is when a system maintains desirable outputs. If a system were unstable, then the inputs would force the outputs to dangerous conditions. Let's look back to the electric iron example. With control, we reach the desired temperature and maintain it. Without control, the system will eventually overheat and catch fire. Next, we will see how control systems are powered.